All right, example 3 says a culture of bacteria obeys the law of uninhibited growth. So I know I'm using this formula here from the first page. If N is the number of bacteria in the culture and T is the time in hours, express N as a function of T. All right. So N, the number of bacteria, and T is the time in hours, express N as a function of T. So all you are doing here is, and this is what it's going to ask you in your homework. You are just writing this, and because it wants it expressed as N and a function of time, instead of A, you're putting N. So this is N of T equals N naught E to the KT power. Okay, your homework is going to ask for something like this, and that's all it is looking for, is for you to use the right variables. Instead of A of T equals A naught, you're doing N of T equals N naught. So B wants to know if 500 bacteria are present initially. So this 500, because it is present initially, this is my N naught. And there are 800 after 1 hour. So this is N of T, and this is T. How many will be present in the culture after 5 hours? So we'll get back to this portion here, but knowing my initial amount, knowing my N of T, and knowing my T, the only thing I am missing here is my K. So I'm going to use the information they gave me to find my K, and then I can answer the question. So I'm going to plug in all of these into my formula for what I have designed them for. So we have 800 equals, my N naught is 500. E, I don't know K, but I know T is 1. So K times 1. So let's solve for the only thing I don't have, which is that K. So I'm going to divide 500 over, which we just did up here. That's 1.6 equals K times 1 is just K. So this is E to the K power. And then to solve for K that's in the exponent position, I'm going to get rid of this E by taking both sides to the natural log. So that cancels, and I'm just left with K. So I have K equals the natural log of 1.6. Now you can put that in your calculator. That's a number. The natural log of 1.6 is about 0.47. But I want to keep this exact until the very end. So now I want to know how many will be present in the culture after 5 hours. So now this is my new T. I don't know how many is going to be present, so I am solving for N of T, and my initial amount's not changing. So we have, I'm just going to rewrite this formula right here, so we can see everything that we're plugging into where. So how many will be present after 5 hours? So now this is N of 5. My N naught is still 500. E, my K we found to be the natural log of 1.6 times 5. So this is just straight substitution. This is plugging and chugging. 500 E, where are you? E to the natural log of 1.6 times 5. Yeah, let's make sure we close that parenthesis there. Guys, the struggle is real over here. Thank you for being patient with me, even though you really don't have a choice, do you? Okay. So we get about 5,200, let's just round to the nearest whole number, 43 bacterias, number of bacterias. Okay. So that's my answer to part B. How long is it until there are 200, nope, 20,000 bacteria? Okay. So now I'm going to write my formula again and plug in what we know. We have N of T equals N naught E to the KT power. I want to know how long, so I know I'm solving for T. This is your N of T, and N naught is not changing from my original part on part B. So I have 20,000 equals 500. E, my K is not changing either. That K is staying the same. So the natural log of 1.6 T. Okay, you've got to get your exponent part by itself. So we're going to divide over 500. And that's going to give me 40. E to the natural log of 1.6 T. So to solve for T in that exponent position, I need to get it out of that. And we'll do that by multiplying both sides by the natural log, because that's the opposite of base E. Okay. So I have the natural log of 40 equals the natural log of 1.6 T. And so now my last step is to divide that over. So T equals the natural log of 40, which is a number, and the natural log of 1.6, which is also a number. So you can't cancel out the natural logs. Natural log 40 is a number, natural log 1.6 a number, so don't cancel those out. And that's going to be about 7.85. And it tells me up here that time is in hours. This bacteria is growing quickly, y'all. Okay, let's try again. The next page is very, very similar here. All right. The population of a southern city is growing according to the exponential law. So that's just another name there for your uninhabited growth. If N is the population of the city and T N is the population and T is the time in years, again, express N as a function of T. Because it wants N expressed as a function of T, You are just rewriting this, but instead of A's, you're putting N's. So N of T equals N naught E to the KT power. So B says if the population doubled in size over 18-month period, and the current population is that was probably loud. I'm sorry. And the current population is 10,000. What will the population be in 2 years from now? All right. So a couple things. Okay. All we really know here is that the population is doubling. So if I go with my N naught here, I know whatever N naught is, that this has to be twice what we started with. So this is 2 times N naught. Okay, the population doubled. So if this is 100, now this is 200. If this is 500, now this is 1,000. If this is 100,000, this is 200,000. Whatever this is, it's doubling here. Okay, the other thing, we have an E, we have to the KT power. The only thing I know is that it's doubling over an 18-month period. Now be careful here, because my time is in unit of years, and they are telling me that this is doubling in 18 months, not 18 years. So when I do to the KT power, which I don't know K, this is going to be 18 divided by 12. I've got 18 months, but it's in unit of years, so I need to divide that by 12 to get 1.5 years, right? All right. I know that when I solve for an exponential, I need to get this exponent portion by itself. So what I would do is divide over my N naught. So it canceled, and I'm left with 2 equals E. Like I said, 18 divided by 12 is 1.5, so this is 1.5K. And anytime my population is doubling, this is what we end up with, right? 2 equals E to whatever power. Okay, so now let's get that exponent out of the exponent spot. So to get rid of this exponent with a base of E, we're going to bring both sides to the natural log. So we have natural log of 2 equals, that goes away, 1.5K. Divide both sides by 1.5, and K equals the natural log of 2 divided by 1.5. Again, I can put this in my calculator. This is a number. I can put this in my calculator and get a decimal equivalent, but I am not rounding until the very end. Okay. So now it says, so we have dealt with this first portion here. Now it says the current population is 10,000. So this is my N naught. What will the population be in 2 years? This is my T. So if I rewrite my formula, we have N of T equals N naught E to the KT power. I'm wanting to find N of 2. My N naught, the current population, is 10,000. So then we have E to the K, which is, we're writing that whole thing. The natural log of 2 divided by 1.5. And that's all going to be divided by my T, which is 2. All of these have been pretty simple to put in our calculator so far. You do need to make sure you know how to put this in properly. This is 10,000. E, parentheses, the natural log of 2 divided by 1.5 close this parenthesis here, and then times 2. So in 2 years, this population is going to be 25,000. Talking about people, so 198. And I'm just going to go ahead and put people, even though it doesn't say people, but we're talking about the population of a city.